Hello friends, once again, welcome to my YouTube channel. First of all, I thank you for taking your valuable time and interest in watching this practical based video. So to begin with, the aim of this video is to demonstrate the step-by-step procedures involved in the estimation of alkalinity in any water samples by adopting the titration method of analysis. For your convenience and information, the content of this video revolves around the following. On the first step, we'll have a brief introduction to alkalinity in water, and in stage 2, we'll see the formula for calculation of alkalinity, and in stage 3, I'll demonstrate to you the procedures for preparations of reagents required for analysis of alkalinity in water samples, and in stage 4, I'll demonstrate the procedure for estimations of alkalinity in water samples, and last but not the least, in stage 5, I'll demonstrate to you the calculation of alkalinity using Microsoft Excel. So to begin with, let us start with stage 1, that is introduction to alkalinity. Alkalinity of water is an important chemical water parameter. When we say we are estimating the alkalinity of water, it implies that we are measuring the capacity of the water to neutralize the acids present in the water. Measurement of alkalinity in water reflects the buffer capacity of the water. That is the ability of the water to absorb hydrogen ions without changing the pH of water. An alkalinity level in any natural water is mainly attributed or caused by the presence of the hydroxide ions or carbonate ions or bicarbonate ion present in the water, which are formed when the water percolates through the soil. As per the Bureau of Indian Standards, the acceptable limit for alkalinity is 200 milligrams per liter and the permissible limit is 600 milligrams per liter. However, this value might change if you refer to other standards, for example, WHO, EPA, ICMR, and other standards. Next, let's move on to stage 2. That is, we will see the formula used for calculation of alkalinity in any water samples. For your information, there are two sets of formula used for calculation of alkalinity. And the first set of formula is if or when the water samples is titrated with standardized sulfuric acid, and the formula for calculation of alkalinity are: first you have to determine the phenolphthalein alkalinity, and the formula for phenolphthalein alkalinity is A into 1000 by ml of samples used for analysis. It is then followed by methyl orange alkalinity, and the formula for methyl orange alkalinity is B into 1000 divided by ml of samples used for analysis. And then cumulatively, we will determine the total alkalinity of the water samples. And the formula for total alkalinity is equal to A into B into 1000 divided by ml of samples. And a question might arise that why do we have to estimate for phenolphthalein alkalinity and methyl orange alkalinity and then total alkalinity? The simple reason is because there are two different indicators that we will use when you analyze alkalinity in any water samples. And those indicators are: number one is the phenolphthalein indicator, and the second one is called the methyl orange indicator. For your information, not every sample that you analyze will have both phenolphthalein alkalinity and methyl orange alkalinity. However, if the sulfuric acid is not standardized, then you can use this other formula. That is, alkalinity is equal to A into normality of the sulfuric acid used into 50 into 1000 by ml of samples. However, for any analysis, it is recommendable if the sulfuric acid is standardized. And to know more about standardization of sulfuric acid, we will be talking about this shortly in the next stage. Next, let's move on to the third stage, that is preparations of reagent. For your information, there are only two reagents that we need to prepare for carrying out this analysis. Before we proceed into the preparations of chemical reagents, for your information, there are 2 points that I would like to share with you. Point number one is the procedures that I am adopting for demonstration purposes in this video is as per the standard protocol prescribed by MIT and AFA. And point number two, to avoid wastage of chemical, prepare the required reagent using minimum amount of chemicals. However, this might change if you have a lot of samples to analyze. For example, if the prescribed book says that dissolve 364 gram of X chemical in 1 liter of water, and if you have only few number of samples, then you don't need to prepare 1 liter of a reagent. So instead, you can weigh on 36.4 grams of the X chemicals and dilute it in 100 ml of distilled water. So this is how you can avoid wastage of chemicals during preparation of reagents. Now let's prepare the first reagent, that is sodium carbonate solution, which is of 0.005 normality. And to prepare this solution, the only chemical required is sodium carbonate. To start preparing this solution, first take a small quantity of sodium carbonate in a petri dish and then dry it inside an oven at 250 degrees Celsius for 4 hours. And then 4 hours later, take it out and let it cool. Then with the help of a weighing balance, weigh 2.6 gram of sodium carbonate. After doing so, transfer it into a 500 ml volumetric flask. Then dilute it and fill the volumetric flask up to the mark with distilled water. Once this is done, then this is a 0.05 normality sodium carbonate, and this will be used for standardization of standard sulfuric acid solution. Next, let's move on to the preparation of the second reagent, that is the preparations of the standard sulfuric acid, which is of 0.02 normality. For the preparation of a 0.02 normality sulfuric acid, two steps will be involved. The first step is the preparations of 0.1 normality sulfuric acid. And to do so, first pipette 1.5 ml of concentrated sulfuric acid into a 500 ml volumetric flask. And after doing so, fill the volumetric flask up to the mark with distilled water. Then the solution prepared is a 0.1 normality sulfuric acid. And for your information, it is from this solution that a 0.02 normality sulfuric acid will be prepared. Now, how are we going to do that? First, we have to standardize the prepared 0.1 normality sulfuric acid against the standard sodium carbonate solution, which is of 0.05 normality. And to do so, first fill the burette with 0.1 normality sulfuric acid up to the 0 mark. After which you can then take the prepared sodium carbonate solution, shake it properly, and then measure 50 ml of it and then transfer it into a 250 ml conical flask. After doing so, add few drops of phenolphthalein indicator into it, and then you'll see that the solutions turn pink in color. Then the next stage is you titrate the pink color solution with 0.1 normality sulfuric acid solution till the pink color disappear. And remember to record the initial and final burette reading. Repeat the same procedure for the other two replicates. Let us say that we have titrated the standard calcium carbonate solution. And let's say that the data obtained are as displayed on the screen. So based on the data obtained, the mean value of sulfuric acid used is 22.8 milliliters or 22.8 ml. Now, using the N1V1 equal to N2V2 equation, we will find out exactly what is the normality of the 0.1 normality sulfuric acid. It's just like we're trying to confirm, is it really a 0.1 normality sulfuric acid that we prepare. So what we can do is, since for N1 and V1, N1 is the normality of the sodium carbonate, which is known to us, which is 0.05 normality, and volume of sodium carbonate used is 50 ml, and the volume of 0.1 normality used to titrate the 50 ml sodium carbonate is 22.8 milliliters. So from here we will obtain the N2 value. So N2 value will be equal to N1V1 divided by V2. So N2 is equal to 0.05 into 50 divided by 22.8, and ultimately this will give us the N2 value, which is 0.109 normality, which means that the normality of the prepared sulfuric acid is correct. However, for calculation purposes, we'll use 0.109 as the normality of the prepared sulfuric acid. Now, once you have confirmed the normality of the sulfuric acid use, then from there we can now move on to the next stage, which is the preparation of the 0.02 normality sulfuric acid. And to do so, we again have to use the N1V1 is equal to N2V2 equation. So from this equation, the desired normality of sulfuric acid that we want is 0.02 normality. And let's say the desired final volume we want to make is 500 ml. And the N2 we already know it, that is 0.109 normality. So the next is how much of this 0.109 normality will we take to prepare to make a 0.02 normality sulfuric acid. So we just have to find the V2 value. So V2 will be equal to N1 into V1 divided by N2. So V2 is equal to 0.02 into 500 divided by 0.109. So V1 is equal to 91.7 ml, which means that we have to pipette 91.7 ml of 0.109 normality sulfuric acid into a 500 ml volumetric flask and dilute it with distilled water up to the mark. And the final solution that we'll obtain is the 0.02 normality sulfuric acid. Okay, so now we have obtained that in our calculation. Now let's do it. So first, take the 0.1 normality sulfuric acid and then measure 91.7 ml of the 0.1 normality sulfuric acid and transfer into a 500 ml volumetric flask and then fill the volumetric flask with distilled water. And this final solution that you obtain is the standard 0.02 normality sulfuric acid, and it will be used for titrations of the water samples. Next, let's move on to stage number 4, that is the estimation of alkalinity in water samples. For easy understanding and for demonstration purposes, let us assume that we are estimating the alkalinity of these water samples. So let's take 3 conical flasks which is of 250 ml capacity, and then into each of the conical flasks measure 100 ml of the water samples using a 100 ml measuring cylinder. Next, fill the burette with 0.02 normality sulfuric acid up to the 0 mark. And after doing so, the next stage is into each of the conical flasks containing the water samples. First, add 1 to 2 drops of phenolphthalein indicator. For your information, there are two possibilities after the additions of phenolphthalein indicator. One is the samples will turn pink in color, and the other is the samples will remain colorless. So in case if the water samples turn pink in color, then you have to titrate these samples with the 0.02 normality sulfuric acid till the pink color disappear. And remember to record the initial and the final burette reading for all the different replicates of the samples analyzed. And the volume of 0.02 normality sulfuric acid used in the titration will give us the A value of the formula, and it is from this value the phenolphthalein alkalinity of the water samples will be obtained. However, in these samples that we are estimating for demonstration purposes, we found that after addition of phenolphthalein, no color appears. So if no color appears, then we move on to the next stage, which is we add 1 to 2 drops of methyl orange indicator. Then once you add methyl orange indicator, you'll see that the solution changes in orange color. So similarly, even for this, you have to also titrate the solution with 0.02 normality sulfuric acid till the orange color turns into pink. And remember to record the initial and final burette reading of all the different replicates of the samples that you analyzed. And here also the volume obtained after titration of the samples will be the B value, and this B value will help us to determine the methyl orange alkalinity of the water samples. And let us assume that the volume of 0.02 normality sulfuric acid consumed for titration of the samples is as given on the screen. Next, Let's move on to the last stage, that is the calculation of alkalinity in the water samples that we analyze by using Microsoft Excel. So to begin with, first open Microsoft Excel sheet, and for easy and smooth understanding of how to carry out the calculation, first let us bring the formula used for calculation of alkalinity in water in this sheet. So as we already seen earlier, we first have to find out the phenolphthalein alkalinity of the water samples, then the methyl orange alkalinity, then at last the total alkalinity. So in order to make the calculation easy, I've already prepared the format of how the data should be arranged. So arrange the data in this format. So we already known that we have only one samples, that's sample A, and for that samples we take 3 replicate R1, R2 and R3. And during the analysis, we have seen that the first step is addition of phenolphthalein indicator into the water samples. So after addition of the phenolphthalein indicator into the water samples, we've seen that there is no color change in the water samples. So which means that the phenolphthalein alkalinity of the samples is 0. So basically this will be just 0. However, we've seen that after addition of phenolphthalein indicator, we then add 1 to 2 drops of methyl orange indicator into the water samples. And what do we see? We found that the water sample changes its color into orange. So when the color changes into orange, which means that we have to titrate the samples with 0.02 normality sulfuric acid. Let's say when we carried out the titration, let's say these are initial reading and final reading obtained for the samples that we analyze. So from here we can find out what's the volume of sulfuric acid used for titration of the orange color till it turns into pink. So we just have to take the final burette reading minus the initial burette reading, and this will give us the volume of sulfuric acid used. So similarly you have to do it for the other 2 replicates. And from here we've seen we can now calculate the methyl orange alkalinity. So methyl orange alkalinity is B into 1000 divided by ml of samples. So we just have to put equal sign here. B is this value into 1000 divided by ml of sample is, we use 100 ml, so it will be 100. So it will be 53 milligrams per liter for replicate 1, 52 milligrams per liter for replicate 2, and 57 milligrams for replicate 3 respectively. Right, so from here then we can take the average. So the mean concentration of alkalinity in the sample we analyze is 54 milligrams per liter. So based on the analysis carried out, we found that the water samples analyzed for total alkalinity was found to have 0 phenolphthalein alkalinity and only methyl orange alkalinity. This clearly indicates that the alkalinity of the water sample was basically due to bicarbonate content only, whereas carbonate and hydroxide ions were absent in the samples. So this is how you determine the alkalinity of any water samples by adopting the titration method. As mentioned earlier, not every sample that you analyze will have both phenolphthalein alkalinity and methyl orange alkalinity. For your information, in case after the addition of the phenolphthalein indicator, the water samples turn pink in color, then you have to titrate it. After you titrate it, you'll get the initial burette reading and the final burette reading, and then you'll get the A value, and after you obtain the A value, then phenolphthalein alkalinity will be obtained. So in that case, then your total alkalinity will be, you have to use both phenolphthalein alkalinity values as well as the methyl orange alkalinity values, and then cumulatively you will give us the value of what's the total alkalinity of that samples. So this is how you determine or calculate the total alkalinity of any water samples using Microsoft Excel. So with that, we now have come to an end of this video. I believe and I hope that This video will benefit students to understand how to carry out the alkalinity estimation in any water samples, and also how to do the calculation and how to obtain the final value or the total alkalinity value. With that, I hope this video is helpful, and if you find this video helpful and beneficial to you, please kindly like, share, and subscribe to my channel. So once again, thank you so much and God blessed.